Now let's start with optical resonant cavity. Laser is a light source and it can analogous to the electronic oscillator. An electronic oscillator, as shown in figure, is essentially an amplifier supplied with a positive feedback. A part of the output of the amplifier is taken and again is feedback at its input. When the amplifier is switched on, electrical noise signals of appropriate frequency present at the input will be amplified. The output is feedback to the input and amplified again and so on. A stable output is quickly reached when the oscillator acts as the source of the particular frequency. This is the diagram as shown, where active medium is surrounded by reflecting mirror and the semi-transparent mirror. Number of multiple reflection, again the ray comes out to be right hand side mirror, which is partially transparent, and a amplified beam of light is obtained. In laser, the active medium is the amplifying medium and it is converted into the oscillator. Though the feedback mechanism is established by the optical resonator, a pair of optically pained parallel mirrors, as shown in figure, constitutes an optical resonant cavity. It is known as Fabry-Perot resonator. One of the mirror is fully reflecting and other is reflected all the light on its, and other mirror is made by partially reflecting, such as more than 90% of incident light is reflected from it and a small fraction of the light is transmitted through it. In laser, the role of noise is placed by the chance photon emitted spontaneously. The photons emitted along the optic axis of the resonant cavity travel through the medium and trigger stimulated emission. They are reflected by the end of mirror and reverse the path. The photons are thus fed back into the medium and travel towards the opposite end mirror, causing more stimulated emission. The photons are once more reflected in the mirror and travel towards the opposite mirror. Substantial light amplification takes place because the light beam is reflected several times at the mirror and again it gains strength in each passes. Ultimately, when the amplification balances the losses in the cavity, the laser beam emerges out from the front end mirror. In the absence of resonator cavity, there would be no amplification of the light. This is the process by which the light amplification takes place. Figure shows the action of optical resonator. The active centers in the medium are in the ground state initially. Though the suitable pumping mechanism, the medium is taken into the state of population inversion. Some of the excited atom emits photons spontaneously in various directions. Each spontaneous photon can trigger many stimulated transitions along the direction of the propagation. As the initial spontaneous photons are moving in the different direction, the photons stimulated by them also travel in the different directions. Many of such photons have the medium without reinforcing their strength. In the absence of the end mirror, the net effect would be the production of the incoherent source light. Now, because the end mirrors, a specific direction is imposed on the photons, photons traveling along their axis are amplified through stimulated emission, while the photons emitted in any other direction will passes through the side of the medium and are lost forever. Thus, a specific direction is selected for the further amplification of the light. The majority of the photons are traveling along the axis are reflected back to the reaching the end mirror. They travel towards the opposite mirror and their way stimulated more and more atoms and built up a strong photon strength as shown in figure. The photons that strike the opposite mirror are reflected once more into the medium as shown in figure. The photons travel once more through the medium, generating more photons and more amplification. The photons are then reflected again at the mirror and travel through the medium. As the photons are reflected back and forth between the mirrors, stimulated emission sharply increases. The amplification of the light is augmented. The mirror thus provides positive feedback to the light into the medium so that the stimulated emission acts are more sustained and the medium operates as oscillator. Each reflection at the fourth end mirror light is partially transmitted through it, and the transmitted component constitutes a loss of energy from the resonator. When the losses at the mirror within the medium balance the gain, the laser oscillation builds up. A steady and a strong laser beam will emerge from the front end mirror as shown in figure. As the end mirror reflects light strongly into the laser medium, the light travels are very high with the optical cavity. Consequently, the condition that rho nu should be large within the medium is satisfied. This completes the laser process. Tomorrow we will start with new topic of